Okay, let's get straight to it. So our first speaker is not actually Matthew's brother, although we've had several questions about that. He is the author of the incredibly popular Ethereum library, revoke.cash, and also one half of the CashScript team. Representing the Netherlands, we have Rosco Kalis with What's New in CashScript.
Clicker, yeah. Cool. Hey guys. Hey. Welcome. So, thank you for the great introduction. My name is Rosco. I am not Matthew's brother. And so, yeah, I've been active in with development in the crypto space since about 2018, 2019. I've created CashScript back in 2019, worked for bitcoin.com, later General Protocols, as well as some other projects in the Ethereum and Bitcoin Cash spaces. Nowadays, I mostly work in Ethereum on revoke.cash, security application. But I still also maintain CashScript together with Mathieu. And so just let's give a quick recap. So CashScript was created in 2019 as part of my master's thesis at bitcoin.com. And initially, the reason why we developed CashScript is that writing smart contracts for Bitcoin or Bitcoin Cash has to be done in a language called Bitcoin Script, which is like an assembly-like language, which is kind of hard to write. So we wanted to develop something that would enable more people to write it. So we have CashScript, which compared to Bitcoin Script has fewer, is less error-prone because it's easier to write, makes it faster to develop, and also easier to integrate within other applications like web apps or desktop applications. And so initially, like I said, I developed it at bitcoin.com. But then in 2020, I joined the General Protocols team. And while I was working there, continued working on CashScript as well. And initially in 2019, the initial release was just the most basic form we had. And after a few months, we introduced an abstraction for Covenant, so for introspection, which back at the time was a lot less accessible than it is today with native introspection. So there was a lot of extra things that had to be done to enable that. And then while I was working at General Protocols in 2020 and 2021, the nice thing was that I was actually able to use CashScript myself and figure out that there were some things that were maybe not as nice. So a lot of time was spent on sort of improving the way the libraries work, the way the compiler works, just to make everything smoother for developers. And so that brings us to what we're going to talk about today, which is the recent developments in CashScript. And with recent, that's a very broad term because we're looking at the past couple of years, but it's been a while since we had a proper BCH conference, so we got a lot to catch up on. So in 2022, the BCH network had an upgrade enabling native introspection, which was a big improvement over the sort of workaround that we had before that. In 2023, which is last year, of course, we saw the CashTokens upgrade that Mathieu talked about extensively yesterday, and that also had some implications for sort of the way people develop smart contracts. Then in 2024, that's this year, we have some really cool upcoming features that I'll share more about in the presentation as well. So just as a recap, for the old way of introspection, you needed a lot of boilerplate code, and the CashScript SDK or the CashScript compiler that abstracted away a lot of that, but it still ended up in your compiled contract. So this is an excerpt of the earlier versions of AnyHedge, and all of that code that you see there is just a prerequisite of using the introspection. So this is no actual functionality in here yet. It's just so that we can use whatever we need in the smart contract. So as you can see, that's just a lot of wasted space. And on top of that, it also caused the already strict contract limits to be even stricter. So overall, there was just so much less that you could fit in a single contract. So in 2022, BCH enabled native introspection. And I just put this comparison in here that the exact same AnyHedge contract essentially went from 193 to 109 opcodes, which is almost halving the size. Or essentially, we can add another AnyHedge contract worth of functionality in the same contract, and like enable all kinds of cool new things. So that's really nice. And we also got rid of the extra strict limits. I know that there's still pretty strict contract limits that we're working on raising or retargeting, as I was made aware of yesterday. And on top of that, this native introspection also just is more powerful than whatever we had before. So there's new things that we can access that were very hard or even impossible to do before. And so anything that is enabled by the native introspection was added to CashScript in the v0.7 upgrade. Then after that, last year in 2023, the BCH network got CashTokens, and Mathieu did a lot of work to get all of this cash token functionality implemented in the CashScript compiler and in the CashScript library. And so CashTokens has enabled us with native fungible tokens. So anyone can issue fungible tokens or NFTs. But from a smart contract perspective, there's a lot of new functionality as well from those cash tokens. That's not just token-based functionality. And so using NFTs and the NFT commitment field, we can now have a sort of local state in smart contracts. So smart contracts can keep sort of state with them inside an NFT. And that is a pretty big deal, because one of the big limitations, I think, in BCH smart contracts as compared to more stateful systems like Ethereum has always been that the applications that you can make without any kind of state are always a lot more limited. And there were workarounds for that in the old system, but now there's sort of a native way to still get a lot of the benefits that you can get from having state without the sort of drawbacks that you have in a global state system. And it enables contract messaging, so you can have these NFTs or tokens that also represent messages or state between contracts. So not just the state cannot just be used inside the own contract, but if you have systems of smart contracts where there's multiple contracts that are sort of interacting together, as we've seen in a few of the recent applications, that's also possible now. And so, as Mathieu already mentioned yesterday, there's a lot of new applications built on top of these cash tokens, and those applications kind of brought us to the next step for CashScript. So we saw a lot of people working on these new applications enabled by cash tokens, and we kind of figured out that in order to do what they wanted to do, CashScript had to be better at certain things. So that brought us to the v09 release, which is the advanced transaction builder. And so what we saw in these new applications built on top of cash tokens is what I already mentioned, that there's now sort of these systems that have multiple smart contracts, and they're interacting in some way, keeping state in these NFTs, reading the state from these other contracts to do something that they want to do, right? So, but the way that the CashScript SDK worked is that you can only use one contract at a time. That's the way these BCH smart contracts used to work. Like you just have one contract, you do something with it, and that would cover like almost every use case of BCH contract. But now you have these sort of complex systems of multiple smart contracts. You kind of want the CashScript SDK to also allow or like enable that functionality. So we built a new, more advanced transaction builder in which you can combine an unlimited amount of smart contracts and smart contracts transactions so that these systems can work together. Over the years, there were also some other smaller updates, like a bunch of bug fixes, a bunch of small improvements, but also the multiplication that was part of the introspection release, new address types, the pay-to script hash 32, adding the ability to also include pay-to pub key hash, so like regular wallets, UTXOs inside your smart contract transactions, which if you did the workshop we had yesterday, you'll see that's a super useful feature as well to, for example, what we did yesterday, where one user buys an NFT through a smart contract, things like that. So that brings us to this year. What are we working on right now? One of the big things is the debugging support. So even though CashScript has been a big improvement in terms of being less error prone, easier to develop than just Bitcoin scripts, it's still pretty hard to figure out what's wrong when your contract fails, where the bug is. So late last year, Mainnet Pat had a flip starter to help us integrate better debugging tooling into CashScript. And since then, we've been working on getting that functionality polished and getting it integrated into the CashScript ecosystem. And one of the big things will be the custom error messages. So that means that whenever an error happens inside your smart contract, you can now see which error it was, what message you defined with that error. You can also add console logs. So you can just anywhere in your smart contract, you can add log statements for the variables and it will log the value of those variables at that time in the execution. And finally, there's also the Bitauth IDE integration. And Bitauth IDE is created by Jason Drazener, and it's a really nice step-by-step debugging tool. So if your transaction fails or if you want to run it through the Bitauth IDE, we will generate a link. And if you just click that from your editor, it will take you to the Bitauth IDE with everything loaded in there. So you can step through it, see what the values are during each step of the execution, and just basically use all the nice features that Jason developed for that IDE. And you'll have a side-by-side view of how the compiled code, so that the Bitcoin script is executing, and which lines and which statements in the CashScript source code that corresponds to. So you'll know exactly where things are failing and how it's failing. And then finally, to bring that all together, we're also adding a local test environment so that where you can run your integration tests, like your automated testing systems for your smart contracts against a local network that uses this new debugging functionality to locally step through the transactions, and you will get the same error messages that you would expect to be thrown in a real environment. So you can use that to make sure that your contract behaves exactly as it is supposed to. So that's upcoming. We're really, really close to getting this released. There's already a pre-release out, so if you would want to use this today, you already can, but there might still be some edge cases that are not exactly covered. So, but yeah, definitely we'll do the full release soon. And then there's also another functionality that is still planned for after that, and that is libraries. So another thing that we saw in the new applications being developed after CashTokens was launched is that these systems of smart contracts, so you have like maybe 4 or 5 contracts that share a lot of code. So they do a lot of the same things, for example, to access the state from other smart contracts. And the way they have to do that now is just copy pasting over the code and changing like one value to something else, which is kind of prone to errors. Like if you copy paste it wrong or you forget to update one of the contracts, that's not great. So what we realized is that it would be really nice if there's a way to share code between smart contracts. And the way we want to do that is through libraries that can be imported into your smart contracts and can be published to NPM or published to like some package management solutions, so that people can also share their libraries for things like state management, hopefully leading to like a bigger ecosystem, because not everyone has to reinvent the wheel all the time. And so initially we weren't planning to do the whole debugging stuff until mainnet Pat figured out how to do that properly. And so this was our big planned feature, but now the debugging stuff is I think it's the debugging stuff is much more useful as a first step, and then this is coming later. So we don't have a set time for this, but I think it will also still help kickstart the whole development ecosystem where people can use each other's code. So if you want to get started on CashScript today, or if you followed our workshop yesterday, you can use the CashScript Playground, which is an online editor where you can just play around writing your smart contract on the left side and seeing your compiled contract on the right side. So you just compile it here, and you can interact with it live on ChipNet or mainnet, even if you want. I'm not sure if I recommend that. You have integrated wallets that you can use as well. So you get everything you need right in the CashScript Playground. And then if you're ready to move on to the next step, we have great getting started guides on the documentation for making the step from here into your own editor. So that's what's new in CashScript in the past couple of years. I think we can take some questions if people have them.
Yeah, does anybody have a question?
Yeah, thank you, Rosco, so much for all that you've done. It's done so much for us at General Protocols. But my question is about compilers are a famous thing that can become kind of endlessly complex and large. And do you have any kind of vision or things that you not the day-to-day stuff that you're working on, but where you see it's going, like where you see compilers for Bitcoin CashScript going?
Well, so I think one direction that we've seen the ecosystem move in is sort of improving the base scripting layer a lot. So as like with introspection, there was already some introspection that was abstracted away by the compiler that now has been integrated into just BCH script proper. So I think that kind of simplifies the compiler as well. So I think we'll probably see a bit more of that with other scripting improvements. But in terms of the compiler, I think we're getting sort of to a place where we're sort of stable. So we also had these features planned for a V1 release to sort of signify that we're at this place where we can sort of develop from. So I think after we have the libraries in there, I think we should have everything that a compiler needs.
I think we had another one here, someone.
Hey, Rosco. So one of the things that came up after the workshop yesterday when we were in town was this sort of, if you've like done something with Ethereum smart contracts before, there's the step of deploying, which seemed to be missing yesterday. I know Ethereum has something like counterfactual deployment or something, but is that a difference? Or with minting transactions, do CashScript smart contracts actually get deployed?
Yeah, that is a difference. So I think with things like CashScript, maybe the BCH contracts will be a bit more accessible to EVM developers, but it's still, the mental model is very, very different. So there's still a pretty big learning curve. And so one of the things that you have in EVM chains is, like you said, deployment. So whenever you create a smart contract, you have to deploy it on-chain, and it lives on-chain, essentially, at its own address. Whereas with BCH smart contracts, it doesn't really exist until it's used, until there's until you spend from it. So you can lock up money inside the smart contracts, but at some address on the blockchain as well. But the actual code, it only gets deployed when you spend from that contract, essentially. So the deployment step is missing when you're developing it.
Do we have maybe one more? I have a question, which is, you said you've done a lot of work, obviously, in the ETH ecosystem, and BCH is kind of at quite a different stage. So what is the biggest difference between the two, and what can we do to bridge that gap and catch up as fast as possible?
So I think the big difference is sort of the way accounts work. So in Ethereum, you have an account-based model, which is basically every address just has a balance and can send from that balance. Whereas and smart contracts have like a state that they keep on chain, whereas in Bitcoin Cash and in other UTXO-based chains, addresses and accounts are more of an abstraction on top of UTXOs. And what that means, I think, is for a lot of people, the UTXO model is a lot less intuitive to work with, because it's a lot different from how we're used to thinking about accounts or wallets, money, and also because of like the way it's abstracted in things like BCH as well. That if you have your wallet, it looks like it's just one account, just as it is in Ethereum, but then under the hood, it's actually very, very different. So I think having a way to, make it easier to sort of reason about, like I think that's the biggest, at least the biggest barrier, is that it's, for a lot of developers, it's a lot harder to reason about, and I'm not entirely sure how we can remove that barrier. But I think that is one of the big sort of issues. I think if it becomes easier to work with UTXOs and sort of reason about it, build systems on top of it, then that will be a pretty big thing.
All right, put your hands together for Rosco.
Thank you.
Good.